Students, today we will introduce some basic parameters of Ethernet switches. In the previous courses, we completed the study of basic computer network knowledge. Now we are moving on to the study of the switching module. First, let's introduce some basic parameters of Ethernet switches. Taking 3G's switch as an example, let's take a look at the Ethernet device interfaces of the switch. The switch interfaces are divided into two types. The first type is fixed interfaces, which are built into the switch during manufacturing. As you can see in the diagram, this switch has a total of 12, 10, 100 millions adaptive interfaces, and 2, 10, 100, 1000 millions adaptive interfaces. The second type is called expansion slots, similar to PCI slots on computers. They can be used to expand the interfaces needed in practical projects. In this switch, there are two expansion slots at the back. We can choose to use 10, 100 millions adaptive interfaces, 10, 100, 1000 millions adaptive interfaces, 100 millions fiber interfaces, 1000 millions fiber interfaces, stack interfaces, and so on. Some switches also have GBIC interfaces, which support a transmission standard of 1000 M. By connecting GBIC modules, these interfaces can be used for both twisted pair cables and optical fiber modules. However, due to their large form factor, these interfaces are gradually being phased out. SFP interface, transmission standard 1000 M, connects many GBIC modules. Compared to GBIC modules, these modules are much smaller in size. They can be used for both twisted pair cables and optical fiber modules. You can see the table below, which shows that the interface can support twisted pair modules, single-mode fiber modules, and multi-mode fiber modules. XFP interface, transmission standard, 10,000 M. Connects XFP modules. It is an optical fiber interface module that can accommodate both single-mode and multi-mode fiber modules. Let's talk about why switches use modular hardware design. Modular design enhances the flexibility and scalability of devices, making it easier to implement hardware redundancy and replacements. We commonly categorize switches into two types: simple modular design switches and full modular design switches. For mid to low-end switches, they are designed as box-type devices with a combination of fixed ports and expansion slots, which is referred to as simple modular design switches. On the other hand, high-end switches adopt a full modular design with separate modules for the control engine, line cards, port access, power supply, and fans, all housed in a chassis. In Ethernet switches, switching capacity is an important parameter. So, what does switching capacity mean? Switching capacity refers to the maximum amount of data that can be processed between the network device interface processor or interface card and the data bus. This parameter is determined during the design of the network device, and is generally used to measure the overall forwarding capability of box-type or chassis-type switches. The measurement standard for switching capacity in box-type switches is that the switching capacity should be greater than or equal to port rate * number of ports * 2, to achieve full duplex, non-blocking data forwarding. For chassis-type switches, The overall switching capacity is equal to line card switching capacity asterisk number of line cards. Backplane bandwidth is a parameter that represents the interface bandwidth between line card slots and the backplane. This parameter is determined during the backplane design and is generally used to measure the backplane's capability in a chassis-type switch. The measurement standard for backplane bandwidth is that the backplane bandwidth should be greater than or equal to line card switching capacity asterisk number of line cards asterisk 2. To achieve full duplex, non-blocking data forwarding. The last parameter of the switch is packet forwarding rate, which refers to the number of packets forwarded per second by the Ethernet interface, also known as port throughput. Its unit of measurement is PPS, packets per second, and the packet forwarding rate indicates the size of the switch's data forwarding capability. It measures the switch's ability to exchange data in terms of packets. One important indicator that determines the packet forwarding rate is the switch's backplane bandwidth, which represents the total data exchange capability of the switch. The higher the backplane bandwidth of a switch, the stronger its data processing capacity, resulting in a higher packet forwarding rate. The above is the content of our class today. I hope everyone can complete the following assignments through the learning process. Short answer question: please list several important parameters of Ethernet switches and briefly explain their functions.